Hello, I'm going to be doing Hooke's law today, and Hooke's law is just saying that the applied force onto a spring is directly proportional to the pull or push onto that spring. We have a bunch of buttons here on the right. We have applied force, spring force, displacement, equilibrium position, and values. So if we turn up the applied force all the way, we can see that the applied force is directly proportional to the spring force, the return force that's happening here. And the only thing that changes in this situation is going to be the displacement of the spring, and that is reversely proportional to the spring constant. So in this situation, the lower the spring constant is, the higher the displacement is going to be, and other way. And then we have a second spring here that you can just like use to check with the other one. In this one, we have a top spring and a bottom spring, and when we apply a force, if we turn on the buttons here, applied force, spring force, components, displacement, equilibrium values, if it shows that it's divided by 2 because they have the same newtons per meter in this situation. They have the same spring force. If we lower the spring force of the top spring, then the lower spring with the higher spring force is going to have more return force from the applied force that we put onto it. We can also use it in this situation, which just shows the difference in displacement. On the third one, we have a bar graph, energy plot, and a force plot. We can turn up the displacement, and it shows us the spring constant is directly proportional to the potential energy that is being shown onto the spring here if we turn on these values. So the higher the spring constant, the more newtons of force it takes to pull it, and the increased potential energy. If we lower the distance here, obviously lower newtons of force that we pull on it, and the potential energy is going to be lower. And let's just say we have it up to max 200 joules. If we lower the spring constant, the threshold for the potential energy is going to decrease in the situation. We could also see that with the energy plot. If we turn up the spring constant, the threshold is going to increase, and there's the joules. Force plots also shows us the same exact thing. It shows us everything is directly proportional with each other. Everything increases, something decreases, everything decreases besides the displacement for the spring constant. And that's going to be the Hooke's law simulation.